today we are going to discuss about how to perform the XOR gate. Okay, so now XOR gate is nothing but the one of the digital circuit. Okay, and it is useful for the arithmetic operations and some of the calculations. So now today's experiment's aim is to study the working of XOR gate and verify its truth table. Okay, so for that conditions, how it look like, you just see this figure. You just see this figure. Now you just see the symbol of this XOR gate. This is the symbol. Okay, this is the OR gate. Here is the one line, and there are the two inputs A and B, and output is Y is equal to A plus B. Okay. Now before that, using this operation and you get for the it's verifying the truth table. Before that, how to make the XOR gate, you just see the second circuit. Here two NOT gates are there. After that, this NOT gates output is connected to the one gate of these two AND gate and OR gate. Means you required to making the XOR gate for the NOT gate, AND gate and OR gate. For this XOR gate, we are using the IC 7486. This is the 7486 IC. Okay, IC nothing but the integrated circuit. It is 14 pin IC. Okay, it will start from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay, now how to identify the pins of this IC? Now you just see here is the notch is there. Okay, from this notch, and here is the IC 7486. From this notch, the below first terminal is the first terminal. This is the second terminal. This is the first terminal and it has to be connected here. This is the second terminal connected to here. Third terminal is connected to here. Fourth, fifth, sixth, 7. Okay, 8, 9, 10, 11, 12, 13 and 14. Okay, this is the pin connection, pin configuration of this IC. After that, you should know the any digital circuit you require the sum of DC supply. Okay, so you have to give the 5 volt DC supply, and that has to be connected for this 7 and 14. 7 is for the ground, means ground, and so 14 pin number is the plus VCC. So you required the 5 volt supply. Okay, so you just see for this circuit, I am just showing you. Here we are making the 5 volt supply over here independently on this board. Okay, here is the transformer. This is the 230 volt supply. This is the 230 volt. Okay, and that has to primary of this transformer. Secondary of this 6 volt transformer is there. It has to be connected to the rectifier, and that output of this rectifier is connected to the filter. And after that, we are using the regulated IC, and this IC is 7805, and you will get an output of this IC. Regulated means constant 5 volt supply to this and this pin. Okay, so now we are just connecting the AC supply to that. You just see here. You just see this. You just see here. This is the LED glowing is that means you will get the 5 volt over here. So by using this multimeter, so you can first you confirm whether your supply is 5 volt DC or not. You just see, this is the 5 volt. DC supply. Okay, now you just see, this is the 5 volt supply. Okay, once you get the 5 volt supply, then you have to connect this to the circuit, means 7 and 14 number pin. This is the ground and it has to be connected to the 7, okay, and plus VCC means 5 volt DC has to be connected to this, means you are providing or connected the DC supply to the your IC. Okay, now for one magic thing for this IC is here this 1 and 2, these are the inputs and third one is the output, means this is the one gate, this is the A, this is the, you just see this is the A and this is the B, this is the pin number 1, you just see this, and this is the B means pin number 2 and 3 numbers output. Okay, this is the one gate. Again second gate is connected to the here 4 and 5, 4 is A, 5 is B, and this is the output. This is for this side you will get the 2 gates and here is the 2 gates. Okay, for this IC you will get the total 4 gates. Okay, so now we want to this is the general conditions of this IC and circuit and all other things. So right now we want to verify the truth table whether this IC is or this gate is XOR or not. So that time you have to see here, see the truth table. Okay, you just see the truth table of this. Okay, so now take the 2 wires. This is the A and this is the B. This A is connected to the pin number 1 and 2 is connected to the pin number 2 means your B, and this output of this connected to here, and that output means 3 terminal. You just see here 3 terminals is connected to this resistance. A resistance is for the your LED. This is the LED positive, and this connected to the ground. Okay, so now first condition is that 0 0, this A and B means A and B 0, that means pin number 1 and 2 connected to the 0. So I am connecting here these 2 pins to the 0. This is 0, this is also 0. Now 0 0 output will be 0. Your LED is off, it is not glowing, that means it is the 0. And by using the multimeter, if you want to confirm it, so you can confirm easily. This is the ground and this is the output. You just see 117 millivolt. Okay, now first condition A and B 0 0, output is 0, it is confirmed. Now second condition is that A is 0, means just see here, this is the A means pin number 1 of this IC 7486 0, and this connected to the 1 means 5 volt. You just see here, and your output is 1, means your LED is glowing, means it is give the sum of the supply. Okay, so now if you want to check whether our circuit is working proper or not, the one terminal of this multimeter is connected to the ground and third positive is for the pin number 3. You just see 1.910 voltage and LED is glowing. Okay, second condition is verified. Now we want to confirm the third. So A is 1, A is 1 and B is 0. Okay, now this is the A means pin number 1 is connected to VCC means 1, and second is for the 0. So now you are just see LED again glowing, means output is high. Okay, and if you want to use the multimeter and you just confirm it, you just see here, you just by using this multimeter you just see here, so it is showing the sum of the voltage near about 2 voltage, means 1.909 2 volt, and LED is glowing, means your output is high. Okay, and last condition is both are the high, then what will happen? So now this is connected to the high. You just see here, your LED is not glowing, means it is off, means both the input high, your output will be 0. When the both are low, means 0, then your output is also 0. By using this multimeter, you just see, I am just show you the output of this. You just see 134.0 millivolt. You just see, this is output. As per my knowledge, you just see, you will see this. Okay, this is the millivolt, and LED will not glow. That means it is off. Now, and this is the way you can verify the truth table of this. Now, internal structure of this IC, you just see this. This is the so now this is the internal structure of this IC. Here is the notch. 1, 2, 3, 4, 5, 6, 7 is the ground. 14 is IC. Dekho, 1, 2, 3 is the output. Here 8 is the output. 9 and 10 are the inputs. You just see from this figure. Okay. And now LED connections is nothing but the resistor terminal. This resistance terminal. Okay. This resistance terminals directly connected to the 3. Okay. This connected here. This is the resistance, and resistance terminal is connected to the positive of this LED, and second terminal is for the ground. Okay, easily you can verify. 0 means low, means 0 volt, and 1 means high volt, 5 volt. Okay, this is the experiment to verify the XOR gate. Okay, now for this XOR gate, where we have to use this IC for the some of the arithmetic applications, some of the big calculations. Okay, the digitally you want to be perform to arithmetic operations, means calculations, addition, subtraction, multiplication. That time this gate is playing a important. Right now so many different softwares and other programmers, they are use the XOR gate for designing the circuit for that particular application, and this is the way this experiment has to be confirmed. Thank you to listen very peacefully.